There. All right, so let's do this. Let's talk about the week. It's a weird week, right? So you guys are only in the building 3 days this week, correct? Because they're giving remote time for teachers to go get the vaccine on Thursday and Friday. So this is the schedule. Today we're going to talk about what's called the stock system of naming. It is one of the hardest systems of naming, but it's not that bad if you got the 2 last week. Tomorrow we're going to talk about formula weight and percent composition. Very easy topic, a little mathy, but you guys will be fine. We're going to practice that on Wednesday. So live Monday, Tuesday, Wednesday. Then Thursday, I guess nobody will have anything to do because you guys would be doing the lab. We'll find some time for you guys to light the Bunsen burners. Obviously, it's not going to be Thursday. However, I'm not going to go out of my way and create something else for you to do just because they changed the schedule on us last minute. So because they kind of took it away from us, Thursday will be just a little bit extra time. I will have office hours if you want to talk or anything like that, but then you just got to make sure you're using Thursday to get ready for your quiz on Friday, which will be all types of naming. I'll show you exactly what that's going to look like by the end of the period today, and then what we learn on Tuesday. Okay, so keeping the same schedule, everything should be good, should be feeling it. So now wherever you're keeping your notes, I would get those out if in your packet. And I know that some people might have done this last week, but maybe you did, maybe you didn't. In your packet, if you can find Ionic Bonds Bell Work B. And you might have already done this. You might not have if you were from the cohort that was at home. But let's just very quickly refresh how to name so far. Okay, you should also have in front of you your periodic table and your polyatomic ion sheet. Awesome. Good stuff. Perfect. All right. So the first thing, whenever you're naming, formula writing, or anything, the first thing you got to do is you got to look at some charges. So I see B is in group 3, so I know that he is a +3. And then I'm looking all over the periodic table, and I don't know what to do with big C and big N. Where should I be looking instead? Oh, I see everybody's got it. Go ahead and look at your polyatomic ion sheet here. Okay. And when you find CN, boom, right there, his name is cyanide, and he has a -1 charge. So I can say -1. Then all you're trying to do is you are trying to make sure we can get these to be neutral. So if I have 1 boron and 1 cyanide, that's not neutral. 2 cyanides, still not neutral. 3 cyanides will eventually make it neutral. Oh, and I'm not sharing my screen. Oh, my heavens to bed blue. And my camera got tilted. What a mess. Hopefully that helps. All right. So then what you're going to write is if you just wrote BCN3, is that going to get you 3 CNs or just 3 nitrogens? That just gives me 3 nitrogens. So in order to write this correctly, you have to write BCN in parentheses. I want 3 of all of that with a 3 on the outside of it. Okay. Perfect. Nice. All right. So then you write the first name, which is boron. And then you write the second name. If it's off the polyatomic ion sheet, you just write it as is. Awesome. I would like for you to do a few of these. Be very careful when you get on the bottom here. Okay. For instance, sodium sulfide. Sometimes people forget that they need to write these neutrally. And they'll just write NaS and call it a day. But that would be absolutely wrong because sodium's a +1, sulfide's a -2, so make sure you write them neutrally. I'm going to come around and see how you're doing because I haven't seen you guys here do any of these yet. I just want to make sure you're feeling okay. And then those of you at home, if you did do this, just hold tight. You're getting out your notes. If you didn't do it, let's do some of these. All right, let's see how we're doing. I got the key up here. Make sure everybody's doing swell because you need this skill in order to be able to do the rest of today. So here we go. So hopefully for ammonium carbonate, you need 2 NH4s to neutralize out the -2 carbonate. Remember, NH4 is in parentheses, and you need 2 of them for every 1 carbonate. Remember, whenever you see a +2, -3, you want to get them both to 6. So that means I need Mg3, and then PO3, I need 2 of them, because this is going to be +6, that's going to be -6. Now it's neutral. That is magnesium phosphite. On the bottom, excuse me, they're usually half sheets, so I keep saying that. When you're doing this here, aluminum sulfide, remember, if it's off the periodic table, you give it an IDE ending. Ammonium nitrite, lithium phosphate, and then barium oxide, IDE. And then the biggest thing you want to make sure is that they are neutral when you're writing the formulas. So sodium's a +1, sulfide off the periodic table is a -2. So I need 2 sodiums and 1 sulfur. Ammonium sulfate, 2 ammoniums, 1 sulfate. Beryllium phosphite, I can see they both need to go into 6. So I have 3 berylliums, 2 phosphites. And then hydrogen is a +1, nitrogen is a -3. So it's going to be +1, -3. I need 3 hydrogens. Okay, perfect. So hopefully you're feeling good with that. Let's get into the last naming system that we have here. So wherever your notes are, let's go ahead and write naming transition metal stock system notes. All right. Good stuff. All right. So we have skipped a large portion of the periodic table for much of the notes and things like that. We didn't talk about their valence electrons. We didn't talk about how to name them. We have been really skipping out. Besides talking about they have their metals in the D block, we really don't talk about these. So we're going to talk about them today. So stock system is used to name the transition metals, or you can call it the D block or the B block down here. And if it was me on my official periodic table, I would write stock system. So I remember. Okay, so I'm talking about anything from scandium to zinc, yttrium to cadmium, anything in that sunken down block there. Stock system. Awesome. Okay. Wonderful. Stock system naming. So don't start doing this with everything now. Sodium chloride is still going to be sodium chloride. Magnesium oxide is still going to be the same. But it's like, what if I wanted to name rust? Rust is Fe2O3. That needs a special name. That is not just iron oxide. That is down here. So it needs to use what's called the stock system of naming. Okay, so we only use this if it's down here. Okay, let's do it. So the number one question that people want to know is they want to know why. Why do we have to do this? Why even? Who cares? And I would jot this down in your notes. Transition metals. So that block down there with the D block. Transition metals can have more than one stable charge. Because they put those electrons into the d orbital, which is wonky to begin with, they can actually be stable with a couple different charges. Transition metals can have more than one stable charge. So I'll just write an example here for you. You don't have to necessarily write this down, but let me show you. Okay. Cobalt can be stable with 3 chlorines, and cobalt can be stable with 2 chlorines. Okay, that's just the way it kind of works. It's the way that cobalt can do. He can either give away 2 electrons, or he can give away 3. So if I just called this cobalt chloride, how would you know which one I was talking about? Okay. Same thing with iron. This is rust. He can be happy with a +3 charge, or he can be happy with a +2 charge. So you have to give them a name so that you know what's going on. So that's what's called the stock system. So the stock system tells you which ion is in our compound. Is it the cobalt +3, or is it the cobalt +2? So the stock system tells you which ion you're working with. Stock system tells you which ion is in our compound. Perfect. Now, Roman numerals are back, so hopefully we know 1 through 8. You should probably have 1 through 8 already on your periodic table. Stock system tells you which ion. Is it cobalt +3? Is it cobalt +2? Is it iron +3? Is it iron +2? It tells you which ion you're working with. So Roman numerals are used. And the notes are going to slow down. I know this is a lot right now. Roman numerals are used to show the charge of the ion. Roman numerals are used to show the charge of the ion. If you're going to make a mistake, you're going to try to tell me the number of atoms. It's not the number of atoms. It tells you the charge. Okay. Perfect. So it tells you the charge. Here's our Roman numerals. If you know them, you don't have to write them down. If you want to write them down, you can, or we can have a very quick conversation about it. 1 is just an I. 2 is just 2 I's. 3 is just 3 I's. Then when you get to something like this, V is 5. If it's before the number, you take 1 away. So this would be 4 because it's 1 less than 5. V is 5. If you tack it onto the end, it's plus whatever. So VI is 6, VII is 7, and you will never go over 8. So if you want to write it down, by all means, please write it down. All right. So the last thing I want you to write before I have you put your pencil down and just watch for a second is I'd like for you to write this little template. The first thing that you're going to do is you're going to write the transition metal name. Transition metal name. This is your template for the stock system. This is how you're going to do the stock system. After the like iron or copper or cobalt, okay, you write the transition metal name. Then in parentheses, these are very small, so make it bigger. In parentheses, you're going to write the metal charge using a Roman numeral. And then you do either the anion name as it is if it's off the polyatomic iron sheet. Remember, if it's off the periodic table, it needs that IDE ending. Okay, so this is your template. Transition metal name, transition metal charge, anion. Either the name or the name with an IDE ending. So then you're like, well, how are we going to do this? And so this is where I'm going to have you put your pencils down. Just relax. Just watch. We got this. We're going to do it. Here we go. If you know something about the negative and you know that it's overall neutral, you should be able to figure out the positive. So let's talk about what's that. We're going to play a little game. It's called What's My Charge? Awesome. Okay. So we'll do this one first. So let's say I have a metal. Pick one of your favorite metals. You're like, you know what today? Silver. All right. If I don't know the positive, but I know that it's overall neutral, and can you look up bromine for me? Bromine has a charge of what when it's stable? It's in group 7, so it has a -1, right? So if I have -1 for a bromine, how many bromines do I have? This whole side is -4, because I have 4 bromines. In order for this to be neutral, what does that charge of the metal have to be? Thank you, positive 4. So what you're going to name this, if you were naming this one, it would be metal, whatever, 4 bromide. Okay, this is the charge. All right, let's take a look at this other one over here. Carbonate. Let's get it together. This is a carbonate on your polyatomic ion sheet. What is the charge of a carbonate? -2. Thank you. How many carbonates do I have? 3 of them. So this whole side is a -6. So in order to be neutral, this side has to be a +6. So this would be metal 6 carbonate. Again, you're telling me the charge right in there. Okay. Now, that's way too easy. We can make it a little bit harder. Let's do it. What's my metal charge here? Now, sulfate off my polyatomic ion sheet is a -2. We agree with that. I have 3 of them. So my whole negative side is -6. However, how many metals do I have over here? 2 metals. What 2 things, it's not hard math, you just got to remember, this side needs to be +6, but each metal has to be what charge to add up to +6? 3. Okay? +3, +3, give me +6. So when you're writing this, you write the charge of 1 ion. Okay, so this is metal, whatever stock system metal it is, 3 sulfate. Okay, we'll try one more, and I want to give you guys plenty of time to practice today. Phosphate is a -3. I have 2 of them, so this whole side is a -6. I need this to be a +6. However, I have 3 metals. What 3 things add up? It's a 2. Okay, so this would be metal 2, and then that is phosphate. Does that make sense? So you only tell me the charge of 1 ion there. So don't write anything on this page. I just want to give you one more. Oh, sorry. Yeah, don't write this either. So when you are writing the formula, you still have to always have a neutral charge. So this tells me, people are like, well, I'm looking up titanium and I don't know what charge it is. This number right here is telling you the charge. This tells you that this is a +4. Nitrate, I look it up on my polyatomic ion sheet, is a -1. So you have to write them neutrally. So it's titanium. How many nitrates do I need in order to be neutral? NO3. If that's a +4 and that's a -1, how many nitrates do I need? I need 4. Okay. Manganese. This again is telling me that this is a +4. Sulfite is a -2. So I'm not going to MnSO3, 2 of them to make it neutral. Iron, +2. Nitride, ide, off the periodic table. That's a -3. Get them both to 6. So that means for my iron, I need 3 of them. And for my nitrate, or my nitride, I need 2 of them. Okay, so the formula writing is no different than you have already been doing. The only thing that's different is the charge is written for you in the name. You can't look it up because there's more than one stable charge for all the stock system metals. Okay, so again, don't write this down. We're just talking. Number 1, this is only for the transition metals. Number 2, metals are always positive, so you can always calculate it if you look up the negative. Then use the Roman numeral, metal name, metal charge, and then the anion name. Don't start using this for everything now. You're like aluminum 3 chloride. No, it's just aluminum chloride, okay? So don't get yourself confused. Let's get you guys doing some practice now. Go to your worksheet. It says compounds worksheet. Stock system ionic compounds worksheet number 3. Let's do it. Perfect. All right, number one is really simple. No, you can't just look at it because there's many stable charges. Let's write this one more time, though. This is your template. You write the transition metal name. Then you write the metal charge in parentheses using Roman numerals. Then you write the anion name. If it needs an IDE ending, add it on there. All right, get to practicing. All right, I went ahead and showed the first one for you. Are we ready? So you break it down, cut it in half from the metal to the non-metal. I know that cobalt is plus something. I have to figure it out. CO3, do I find that on the periodic table or on the polyatomic ion sheet? Polyatomic ion sheet, that's a carbonate. What's the charge of a carbonate? Minus 2. If my carbonate's a minus 2 and I only have 1 cobalt, what does the charge of that cobalt have to be in order for it to be neutral? You got it. Plus 2. So that means I have 1 cobalt at a plus 2, 1 carbonate at a minus 2. Is that neutral? Yes, it is. So the charge of one of these bad boys is what goes in the next column. That's a plus 2 charge, friends. Then you have to write it using the stock system. This is cobalt. In parentheses would be 2 I's. And then carbonate. Cobalt 2 carbonate. It's telling you the charge. Perfect. Let's do another one. How many chromiums do I have in this next one? I only have 1 chromium. How many sulfates do I have, though? Sulfate, sulfate, sulfate. What is the charge of 1 sulfate? SO4 is off your polyatomic ion sheet. That is -2. So my whole negative side is what? -2, -4, -6. That 1 chromium has to then have a charge of what in order to be neutral? The whole thing has to be, you got it, +6. Put it in there for me, +6. Then when you're naming it, you're going to write chromium. In parentheses, you're going to put a V and an I because that is the charge. And you're going to call that a sulfate for the anion. So those two should have been easy. Let's add a little bit harder. We'll turn up the notch just a touch. All right, all right. Now you can see we have more than one of our stock system metals. I have not 1 titanium, but now I have 2 titaniums. So I got to figure out what the charge of 2 things is. And I have 3 carbonates. I know that each carbonate, again, is a -2. So I'm going to say -2, -2, -2. So the whole side for the negative is a -6. What 2 things add up to +6 that each of my titaniums now have to be? Woo! That's what I'm talking about. 3, 3. So the charge of a metal is 3. Do not tell me that this is a +6. I understand that the total has to be a +6, but I want 1 ion. 1 ion. 1 ion. Beautiful. So that's for titanium 3 carbonate. Let me know if you have any questions so far. We're going to go backwards. So going backwards is super easy because it's exactly what you've already been doing. Now, if they give you the name, you're like, I don't know what to do. You're going to do exactly what you did last week. You're going to say, oh, it's iron. I can't look up the charge, but you know what? I'm lucky. That tells me that this iron is +3. You have to do less work. It already tells you the charge right there. So that is a +3. Sulfide, IDE. IDE, so it's coming off my periodic table. Sulfide, the charge for a sulfur is -2. So this number automatically goes over here because that's the charge of my metal. Now, if I have one iron at a +3 and one sulfur at a -2, is that neutral? Bummer. On another sulfur, is that neutral? Bummer. On another iron, did they get them both to 6? Absolutely. So I'm going to say Fe2S3. So exactly the way you were doing it last week is how you write the formula. Okay. Let's see if you can't finish this last one by yourself. And then on the back, I just want to let you know that this is the stock system here, the top half. But your quiz on Friday, if you listen to nothing else in the next 20 seconds, this is how your Friday quiz will look. They're all mixed in. So for right here, this is just ammonium bromide. Don't you start to put parentheses in there. This is the regular naming. What I would do, I would take my periodic table and I would say, oh, get a star next to silver because that's in the stock system. This doesn't need a special name. That doesn't need a special name. Oh, yeah.
We got another code 9, just FYI. Catch you later.
Manganese needs a special name because it's in the stock system. So if it's down in the stock system, you have to give it the special name. If it's not, you just write, oh, what's this? Sodium hydroxide. Okay. And then when you're doing the formulas, they have to be neutral. Okay. I'm done talking for today. You guys have 10 minutes. The key is online, and I also have 3 really easy lecture questions for you. One of these on the front is actually one of your lecture questions as well. So if you want to get into your lecture questions, bring up the key, start to do some of these. I'm walking around, checking in at home, all that kind of good stuff. But this is on your quiz on Friday, the last naming system. Good stuff.